Go.
Streaming from South Africa to the world. This is the Stonks Go Moon podcast. What just happened? We break it down so you don't have to.
Welcome everyone to the Stonks Go Moon podcast. My guest today, Eric Vreeland, is the Chief Strategy Officer at Polyhedra Network. Welcome to the pod.
Thank you very much, Rocco. Happy to be here.
So I started talking about ZKPs, I think a year or two ago, and people were like, ZK what? And I think people are still going to, if you say ZKPs, they're going to still say, what the heck are you talking about? So I think today, let's break that, start before we fundamentally move to anything else. What exactly is zero knowledge proofs, ZKPs?
Sure, absolutely. So zero knowledge proofs are the ability to prove a statement is true without revealing any additional information about what you're trying to prove. So a good example that someone told me recently was, let's suppose that you're colorblind and someone hands you two billiard balls and they say one of these is red, one of these is green. And I'm going to prove that to you without revealing any information. So one way that you as the prover could do this is you could put the two balls behind your back.
Okay.
And you could reveal one and then you put it behind your back, and then you could either mix them up, or you could show them the same one again and ask them, did I change the ball that I'm showing you? And if they were two different colors, they would be able to tell you, yes, you switched the ball behind your back, or no, you didn't switch the ball behind your back. And they still are not revealing to you which one is red and which one is green, but they are verifying, in fact, that one of the balls is red and one of the balls is green.
Right. So how does that work? How does that translate it to tech? Is it zeros and ones, or what are we talking about?
Yes. So exactly what you're doing there's a number of different methods with which to do it.
Okay.
But, there is cryptography involved. And so you're committing to some information beforehand. You're generating a proof, and the verifier using that information that you committed beforehand is able to verify that your proof is true without actually having to recalculate and recompute. So one of the properties of SNARKs that is very important is that it's succinct. Now, let's say you wanted to...
Sorry, what is a SNARK?
Yeah. Succinct acknowledgement of and arguments of knowledge. So that is ZK-SNARKs. So SNARKs are these ability to verify computation was done correctly, succinctly. And ZK adds this element of no other information is revealed. So for the succinct property, you can think about an example of this is a Sudoku puzzle. It could take you hours to solve a Sudoku puzzle, but you can verify very quickly that a Sudoku puzzle was done correctly. All you have to do is add up all the rows and columns and add up all the boxes and make sure that they sum to the specific number. Now, for you to redo that computation would take a lot of time, but for you to verify that computation was done correctly, you can do very quickly. And so the key element of, or one of the things that SNARKs enables is for you to verify computation was done correctly in a very short amount of time. And so you can use this as it's related to the blockchain. Let's say you want to verify that a transaction is valid, or you want to verify consensus of a particular blockchain. You can do this by creating a zero knowledge proof or a ZK-SNARK. And then you can verify that those computations were done correctly in a very efficient manner.
Okay, but stupid question. I thought that's what we had blockchain for. It points to a ledger entry, sort of that is it. It's immutable. It can't be anything else. So why do we need ZKPs?
So there are a lot of computation that would be incredibly expensive to do on chain.
Okay.
And so what what zk-SNARKs enable is for you to do this computation off-chain. Let's say you want to train an LLM off-chain, but you want to generate a proof that proves that the computation or that the training of the model was done correctly and that it was done using a data set that you had approved. You could create a proof and then you can post that proof on-chain and you can verify that proof on-chain. And so it allows you to unload a lot of this computationally intensive work off-chain and still make it verifiable on-chain.
Okay, that makes 100% sense. Tell me, ZKPs the average user interface when I'm on the internet or I'm doing something crypto, whatever, I'm not really going to see it. So what are the use cases going to be? Meaning, at what backends are ZKPs with some of the things I'm interacting with at the current stage, if that makes sense?
Yeah, absolutely. So I think we're seeing a lot of interest in ZKPs for scaling blockchains. And it's for the same reason that we just talked about. You can offload the compute to some place where it's cheaper, where block space is less expensive, where the block times are faster, and then you can use a zero knowledge proof to prove that the transaction is valid, the sender had enough of a particular token to send, that it is included in the Merkle tree, and then you can post that proof to mainnet or to Ethereum in order to kind of reconcile that with the layer 1 chain. So that's if you're interacting with Linea or Scroll or any of these kind of ZK-rollups, they're definitely they're utilizing this technology. Another one is interoperability. So you can use zero knowledge proofs to prove the state of one chain and then verify it on another chain. And so let's say you want to send 100 tokens from Ethereum to Arbitrum. Yeah. You can then create a zero knowledge proof that 100 tokens were burned or 100 tokens were locked on the sender chain. And you can verify that proof on the receiver chain and then unlock those tokens or mint those tokens on the receiver chain. So it's a way to share state in a tamper-proof and verifiable manner between blockchains, because blockchains were architected in this way of very monolithic. Like, we can verify that all the data on our own individual blockchain is correct, and it's been you can prove it mathematically. But as soon as you get to the point of trying to share data in a trustless manner between blockchains, they're not meant for that. And so you need to introduce this new kind of technology. And there are other ways to do it. I think the most common other solution for this is some sort of validator network that sits in the middle that has validators sign off on the authenticity of a state of one blockchain, but you're introducing additional trust assumptions. You're trusting this validator set, whereas with zero knowledge, you're just trusting the mathematics and the cryptography and the zero knowledge.
Yeah, 100%.
And then I would say the last one that ZK is, I think when it was first becoming popular and people were first starting to learn about it, is obviously privacy. And so, there are these privacy protocols like Zcash that utilize ZK early on. Where we're starting to see a lot of interest in zero knowledge is from who? From who?
Interest from who?
I would say traditional financial institutions that want to figure out how to utilize blockchain, but they don't want all of their transactions to be public to everyone that interacts with their blockchain. Obviously. And so you can use ZK to enable obfuscation of transaction data. So sender, receiver, amount transferred. You can also architect it in such a way so that it is compliant, and so that if someone, let's say there's a compliance entity that wants to reveal the underlying information, they have the ability to do so.
How difficult is it to integrate ZKPs into traditional finance infrastructure?
The solution, the architecture, we have built something. We have a few POCs that we're working on right now. I think working with traditional finance is always takes a little bit longer because, they have so many customers.
Yeah.
They have so much value at risk. They have so much reputation at risk. So they want to move very, very prudently.
Carefully,
and ZKPs are relatively new technology. So I think what we'll start to see is these being rolled out as kind of innovation projects within a small group or a contained use case. And then when there's success there, we will start to see it expand. But I would say there's lots of interest in the traditional finance space. And it is just going to be a matter of time before we start to see large scale projects rolling this out. Because, I think this idea of privacy, scalability, verifiability are all things that are appealing to those institutions.
So what about neobanks like Revolut? Would they accelerate this process because of their innovative ways and taking on, basically becoming the de facto challenger banks to the traditional banks?
I think that there is, the traditional banks are in maybe have an advantage because they have so much experience understanding the regulation and understanding what needs to be satisfied from a compliance perspective.
Because they wrote the regulation.
That might be true.
My words.
Exactly. And so, I do think that banks like Revolut have an opportunity to move quickly and kind of roll these things out in a faster manner.
Yeah.
What I think you may see is that they may have to be careful and make sure that they're adhering to all of the different, regulation and requirements from a compliance perspective, which, as we know, varies greatly based on region, based on use case. And so, that in itself might be one of the reasons that it would slow a company like Revolut down.
Yeah. So let's talk about one or two projects that you were involved in, the one being expander proof system. What exactly did that do for you guys?
Yeah, so I lost you on the video. I don't know if that was intentional.
I went into the metaverse for a bit. I'll be back
okay.
kind of when I'm back, but yeah, just
no problem.
I'm okay. Just go on as if I'm here.
All right, I will definitely. So Expander is our own proof system that we have invented in-house and then that we have now open source. Yeah. And it utilizes a technology called GKR, which allows for very efficient proof generation. So the key element that we were trying to focus on with Expander is the speed of proof generation. And why we were focusing on this was because of the first use case that we were going after, which was interoperability with our product ZK Bridge. And I explained earlier how it works with the generation of state and the sender and receiver chains.
Yes.
But as you know, if you have ever bridged assets, people don't want to wait for their assets to be bridged from one chain to another. No. In fact, that could be some of the most anxiety-inducing times in your, crypto interactions. If you are, especially if you're moving large amounts of money from one chain to another. And so we needed a proof generation and a proof system that could generate proofs very quickly. And so because we were born out of a research institution, our founders had the technical acumen to continue to innovate on GKR and to introduce some of our own optimizations into Expander. And because of that, we were able to kind of create a bridge that utilizes ZK, where ZK proof generation is not the bottleneck. In fact, all of our proofs can be generated, faster than the block time.
Wow. Okay.
And because of that, the ZK proof generation will never be the bottleneck. And so that's why we developed Expander. And now we are realizing that there are a lot of other use cases beyond interoperability where Expander could unlock use cases that were previously infeasible. And we're working on getting teams that are developing with ZK to adopt Expander as their proof system of choice.
Oh, that's awesome. Then the second one being the work that you guys are doing with Google launching Proof Cloud. What's that?
Of course. So you'll see a theme here. Our goal with Polyhedra is to make developing with ZK more accessible. And so with Expander, we focused on making them more performant so that they could satisfy a lot of these use cases that require high throughput or low latency. With Proof Cloud, we realized that another bottleneck or another hurdle for developers was the spinning up of the infrastructure or the cloud compute necessary to run a prover, because proof generation is a very computationally intensive process,
costly
and costly. And we also realized that with ZK Bridge, the demand for proofs can vary and fluctuate very wildly. During the daytime, it can be very high. At nighttime, it can be very low. If there's a airdrop, or if there's an event that causes people to move tokens from one chain to another, there can be a high demand. And so we would see that on average, the capacity for the compute that we were renting in the cloud was about 30%. And so we tried to think about ways that we could make this more efficient. And so one, we partnered with Google Cloud to use their infrastructure, working with their auto scaling tools. But as well, we realized that if we can have multiple projects utilizing the same compute, we can pack more proofs into an individual system. And so we can auto scale the number of systems that are, or computers that are running, and we can also optimize the amount of utilization on each of those systems as well.
Oh, that's basically what it's about, right? It's that trying to bring down energy cost, energy consumption, energy cost, and all those things.
Absolutely. And so we're really hoping, if you're a large company, if you're one of these ZK rollups, you're probably have a DevOps team. You're probably doing this all in-house yourself. But if you're an early stage company that is just getting started with implementing zero knowledge, you probably don't have the manpower or the expertise to want to do this yourself. And so that's really what we think that Proof Cloud enables, is for someone to quickly spin up the infrastructure that they need and to not spend a ton of money doing it.
Man, I love it. The democratizing access. It's with such an awesome era that we're living in. Eric, thank you so much for joining me today. If the listeners want to connect with you or Polyhedra, where can they do that?
Sure. On Twitter, Polyhedra is at PolyhedraZK, and I am at Vreeland, V as in Victor, Reeland. My DMs are open. Looking forward to talking with anyone.
Awesome. I'm going to put all the links in the comments. Thank you so much for joining me today. And to our listeners, peace, love, and prosperity. I'll catch you in the next one.
Cheers. You feel my love, but the rest stays concealed. I'll prove my heart in every little move. Zero knowledge, yet my love is true. You don't need to see the scars I've earned, or the battles fought where my heart is burned. With every word I let you in close, but some pieces of me I'll never expose. We dance around the edges of what's real. I'll share my life, but not every detail. I'll show you my love in every sign, but some parts of me will stay confined. I'm an open book with pages sealed. You feel my love, but the rest stays concealed. I'll prove my heart in every little move. Zero knowledge, yet my love is true. I'm an open book with pages sealed. You feel my love, but the rest stays concealed. I'll prove my heart in every little move. Zero knowledge, yet my love is true. I feel the pull, but I won't let my guard be dull. You'll see my truth where it counts the most, but the rest of me, I'll hold it close. I'm an open book with pages sealed. You feel my love, but the rest stays concealed. I'll prove my heart in every little